Welcome to Methamphetamine. Today we're gonna discuss the integral of 1 over a squared minus x squared and why it has 3 different answers. So it depends on the domain and which one you should use. But if you ignore all the domain, you just need to use the L1 version. And I'm going to just start doing this integral. To do this integral, we're gonna use our partial fraction. First, we're gonna factor this. You get a minus x times a plus x like that. This is really easy, right? And here's the deal. I'm going to use the partial fraction, so you can split it to 2 different fractions plus x like that. And then we're gonna figure out what's the constant here. Whenever you see a power of 1 like that, you just need to use the carve-out method. Carve out the a minus x, and how can we let a minus x is equal to 0? Yes, x need to be a, and then put a into it, you get 1 over 2a. And how about a plus a? How can we let it equals to 0? Yes, x need to be negative a, put negative a here, you're still gonna get 1 over 2a like that. So over this integral, 1 over 2a is just a constant, never mind. We can also just factor out the 1 over 2a like that. And here's the deal. 1 over a minus x, first you get ln epsilon of a minus x like that. I think I should leave more space like this. And then. But don't forget about the chain rule. You're gonna divide by negative 1 like that. So multiply by negative 1, they are the same. And the second one, the integral of 1 over a plus x, pretty much just positive ln epsilon of a plus x. This is really easy, right? So overall, you get 1 over 2a ln. And here is the deal. We can just combine the logarithm, a plus x, and then minus that, so you can combine into ln epsilon of a plus x over a minus x like that, plus c. And okay, if this is 1 over x squared minus a squared, you just need a negative here. And then if you need a negative, you can also put it inside, and then you can switch the order. So you can do reciprocal. This equal to, whenever you integrate 1 over x squared minus a squared is equal to 1 over 2a times ln epsilon of a minus x over a plus x. But if you just put down negative, that's okay. Negative 1 over 2a times ln epsilon of a plus a x over a minus x, that's okay. But here, this form looks familiar. If we ignore the epsilon here, here's the deal. If we assume that we can ignore the epsilon, 1 over 2a ln of a plus x over a minus x like that. Here's the deal. We can also just switch the order. We have 2 different forms. 1 over 2a and then ln of x plus a over x minus a like that. Here's the deal. This one. But this is not a though. If this 1, this should be 1. 2 different form, like another epsilon you get 1 over 2a and then put 1 inside the a like that. ln yes, crazy. It's 1 over 2a times ln of 1 plus x over 1 minus x like that, and then another one is 1 over 2a and then 1, but this time it's x plus 1 over x minus 1 like that. And this is equal to wait a minute. And here's the deal. If we ignore the absolute value, we have a familiar form like that. 1 over 2a and then ln of 1, no a. It should be just 1 over 2 like that. 1 over 2 times ln of 1 plus x over 1 minus x. And another one is 1 over 2 times ln of x plus 1 over x minus 1 like that. And this is equal to, you can check the definitions of the inverse hyperbolic function, and this is equal to inverse tangent of x. And this one is equal to inverse cotangent, inverse quash. I like to pronounce this as inverse quash x like that. So here's the deal. Whenever a is equal to 1, you get what? Put 1 into it. You get the integral of 1 over 1 minus x squared like that. And then you just need to put a 1 here. You get 1 over 2 times ln of 1 plus x over 1 minus x like that. And you can just change into the inverse tangent. But here's the deal. The derivative of these are exactly the same. You can also check the videos of the derivative of these two functions. When you do the derivative of inverse hyperbolic tangent, you can just try to differentiate this. You get 1 over 1 minus x squared. When you try to differentiate inverse hyperbolic cotangent, or this equal to inverse quash, this one also gonna give you 1 over 1 minus x squared like that. And here's the deal. Here's the domain problem. Let me just consider the integral of 1 minus x squared like that. Integral of 1 over 1 minus x squared like that. You can just apply this formula, put a into it, so this just 1/2 times ln absolute value of our a is just a squared, right? 1 square is the same. So this is just 1 plus x over 1 minus x. So we know that inverse hyperbolic inverse tangent of x is equal to 1 over 2 times ln of 1 plus x over 1 minus x like that. And then the inverse quash of x is equal to 1 over 2 times ln of x plus 1 over x minus 1 like that. And here, if we want to change it into 1 over 2 ln of ln parentheses of 1 plus x over 1 minus x, we need an absolute value here because we don't want a negative. But you cannot, here is the deal. X cannot be equal to 1 or negative 1. At the moment, if you put 1, you get 0, and negative 1, you will get 0 inside lower sum, and that's not okay. And here is the deal. If you want to get rid of the absolute value here, you get here. And here we want the inside to be a positive number. So when x is equal to 0, that's okay. When x is equal to 1, exactly 1 and negative 1, and that's not okay. And when x is greater than 1, consider greater than 1, you get this negative, just negative. And so we know that x cannot be greater than 1. If you put a negative 1 smaller than negative 1, you get a negative, still get a negative value inside the logarithm. So if I plot the number between 1, negative 1 and 1, and 1 and negative 1 are not included. For example, if we plot 0.5 like that, so you just get a positive inside. 1 minus 0.5, 0.5, and then on the top you get 1.5 over 0.5 is a positive number, so this is okay. So we can change it into this whenever x is between of negative 1 or 1. So you can also put negative 0.5. You still get a positive number inside. So we do not put down an equal sign because it cannot be 0. Cannot be 1 and negative 1. You get 0 inside logarithm. So we can just change it into our hyperbolic hinge like this. Hyperbolic inverse hyperbolic tangent. Or you can pronounce it as inverse tangent. Let me just pronounce it as inverse tangent. Next, and don't forget about the plus c and also this. We can just use this form, but if the original question doesn't give you a domain, you can just put down whatever you want, inverse tangent or inverse. And here's the deal. If you want to get a 1/2 times ln of x plus 1 over 1 minus x here, what should we need? It should be x minus 1. If we want to change it in form of the inverse cotangent, inverse cos x, what should we do? ln of x minus 1, x plus 1 over x minus 1 like that. And here's the deal. When x is 0, and that's not okay, you get a negative inside logarithm because we know the absolute value. So x cannot be equal to 0. When x is greater than 1, we already know that x cannot be equal to 1 or negative 1. So pick a number that's greater than 1. Put a 2 here, consider 2, and then this is just 2 plus 1 is 3, and then over 1, 2 minus 1 is 1, and then 3. You get a positive number inside the logarithm, so that's okay. And pick a number, pick 0.5, consider 0.5 like that. 0.5, you still get a negative value. Whenever x is smaller than negative 1, you put a negative 1 like that, negative 2 like that on the top. You get this equal to negative 1, and then negative 2 minus 1 is negative 3, and that's okay. Negative, they are cancelled, and then you get a positive number inside. So the domain of this, if you want to change this into this, the domain should be x is smaller than negative 1 or x is greater than 1. So you can just change it into hyperbolic quash, inverse quash x. This kind of hard to pronounce this. I'm sorry, guys. You can just, whenever a question tell you to integrate this, you can. If the original question doesn't give you the domain of this, so you can just choose whatever you want. And okay. Let me just write down the formula here. You can prove it by yourself. And this is just this one. This is also equal to, because it's 1/a squared minus x squared. You're gonna use the positive version, and this is equal to 1/a times the inverse tangent of our x/a plus c, and then 1/a times inverse cos of x/a plus c. Here is the x/a. Consider this our y. If this is y is equal to x/a, and y should be between of negative 1 and 1, but just another domain. That's never mind. So the formula of 1/a squared minus x squared, you can choose any one of them. So here, but I still gonna show you some more example of this. And when should we use this? Or you can just use this. That's totally fine. This is the better one, the best one. You can just use this. So consider here, if you want to integrate 1/x squared minus a squared, you just need to switch the order. And as I mentioned before, this equal to 1 over 2a times L1 of epsilon f, epsilon value of a minus x over a plus x, and this just put it down on the negative side. This totally fine. If you integrate 1 over x squared minus a squared, switch the order. So you're gonna put down negative side. So here is the diff. Consider a definite integral is integrate from, let me just 0 to 1/2 like that, 1 over 1 minus x squared dx. If you don't want to use this, so which one do you want to use? And 1 over 1 minus x squared, we know that is equal to inverse tangent x or inverse cos x, right? So here, let me just write down two different situations. Consider this tangent x like that, tangent x from 0 to 1/2, or another one is inverse cos of x and 0 to 1/2 like that. Here's the deal. We already know the form of this is equal to 1 over 2 times ln of 1 plus x over 1 minus x. Put 0 and 1/2 like that. And then this one is equal to 1/2 times ln of x plus 1 over x minus 1 like that. Put down a 0 and 1/2. And here's the deal. We know that if you want to use the inverse tangent, x should be between -1 and 1, and -1 and 1 are not included. So this between -1 and 1, right? 0 to and 1/2 like that. If you put 1/2, you just get a positive number. If you plus 0, this just over minus 0, and that entire you just get ln1 and then 0 like that. So this will give you a positive number. So let me just erase this. This will give you a positive number. And the inverse tangent of 0, we know that this is equal to 0. Like that. So this answer is just equal to inverse tangent of 1/2 like that. You can also use the L1, never mind. But how about this? We know that if you want to use inverse cos of x, x should be smaller than -1, or x is greater than 1 like that. But both of them are not acceptable. The lower limit and the upper limit. If you put a 0 inside, you get a -1 inside the lower sum, and it's undefined, you know, ln of a negative number. And if you put 1/2 into it, you still get a negative number inside. So we can call this integral. We only use the hyperbolic tangent x, and we don't call it diverge because it actually have the answers if you use the inverse tangent. And this is the answers of this. But second one, second situation like that. From 0 to 1, you see what happened. The integral of 1 over 1 minus x squared from 0 to 1. But let me tell you, this integral diverge. Because if you want to use the inverse tangent x should be the lower limit and upper limit should between -1 and 1, right? But you know that -1 and 1 are not included, and 1 is not included. If you put 1 inside the inverse tangent, you will get undefined. But it's the same as inverse cos. If you put 0, 0 is not okay too, and 1 is not okay too. Inverse cos of 0 is undefined, and inverse cos of 1 is undefined. You can check it by the L1. You can put it inside L1. So this one pretty much just diverges. Diverges. This is the effort like that. So this integral diverge. So pretty much, let me just show you another example. Integral, let me think. Integral of 1 over x squared. Let me just plus 6x and then minus 11 like that dx. Here's the deal. I'm going to do this integral by computing the square. So you just need to get x squared plus 6x, and then we're gonna take about half of this coefficients of 6x is equal to 3, and then square that. And then don't forget to subtract as well. Minus this. Let me just add 11 like that. Add 11. So over this one, you will get x plus 3 squared, and this is 11 minus 9. This we don't want a positive number. We want a negative because we're trying to get this. So how can we get a negative? Let me just add 2 like that. Add 2. Make the question like add 2. Add 2 like that, and then 2 minus 9 is just negative 7 like that. This. So we can change this 7 into square root of 7 and then square that like that. So we can just use, but this time, but I'm going to write down the answers. But this time we're gonna switch the order because 1 over x squared, right? This time is 1 over, if you let u is equal to x plus 3, du is just equal to dx, so you don't need to worry about the chain rule. So here is the deal, we can switch the order. 1 over x squared minus a squared, you need a negative. Let me just choose a random form because the original integral doesn't give any domain of this. So let me just use cotangent. Inverse cosh is called. So pretty much just give a negative and then 1 over a and then time the inverse cosh of the inside x plus 3 and then divided by square root of 7 plus c like that. Whew. And that's pretty much our video. So you can also use the L1. I think L1 is the best, but I think this kinda, I don't like this too much, so I recommend to use this because I like to use this, and I like to use 1 over 8 times the inverse tangent more because we know that we have another formula, right? The integral of 1 over a squared plus x squared dx like that. You can let x is equal to a tangent theta, and you will get a formula, and this equal to 1 over 8 times the inverse tangent of x plus a like that plus c. And this looks really familiar. If this is a squared minus x squared, and you just need a tangent. If this is a negative side, you will get an inverse tangent in the h here. So I like this form more, but its domain is pretty small, between -1 and 1. So I think this is better, inverse cosh. So, but this is the best. So because it can be a negative number inside the L1, you need an absolute value here, right? So this one is the safest. So I recommend this, but I think this is better.